Okay, so we deal with this type of problem earlier in the course. This is a new way of approaching it by using parametric equations. You're launching an item at an angle and an initial velocity. So gravity is eventually going to pull that item down, right? You've launched it in this direction, but it's not going to go in a perfect straight line and eventually come back down to Earth. So that's why our text has this equation. Although this is pulled from Newton, I don't know if the text uses different letters or not, but basically it's a matter of plugging in the information into this formula and then seeing which one it matches up. This is y of t. Oh, I forgot x of t. Hold on. Okay, so the initial velocity is 125. So for x of t, using the formula our textbook derived, you plug in 125 for v sub 0, and then it's cosine 15 times t here. And then for y of t, it's negative 1/2 times the gravitational constant, and since we're dealing with feet, I think it's 16. I think it's 4.9 if you're dealing with meters per second, but I'm pretty sure it's 16 for feet. I can't remember if it's 16 or 32. I don't know why the number 30. No, it is 32. 32. So if you're dealing with feet per second, then the gravitational constant for acceleration is 32 feet per second squared. And then if it's meters per second, it's 9.8. Those are just like known values. So this is meters and this is feet. That's what you plug in for g. And then it's negative 1/2 times g times t squared plus our initial velocity 125 sine of 15 and then plus the initial height of 10. Okay, and I don't even think we have to simplify these. I think we just have to pick the right answer. X of t needs to be 125 cosine 15 degrees. So all these are out because they have the wrong x of t, right? So the right y of t, it's this one because the second one uses meters per second's gravitational constant. So that's our correct answer. And the next part's what's the location after 2 seconds? This is where you just plug in 2 into both of these parametric equations for t. So x of 2 is going to be 125 times cosine 15 degrees times 2, and y of 2 is that simplified to be negative 16 times 2 squared plus 125 times sine of 15 times 2 plus 10. So you're really just plugging in t equals 2 into both of them and simplifying with the calculator. So I'm going to do the trig value first. Oh, I got radians though. Okay, cosine 15 times 2 times 12. So for an x coordinate, I got 23.18. And then for a y coordinate, I'm going to do, here I'll do this middle term first. Need to do 15 sine times 125 times 2. 64.7 here. I'll copy this to my clipboard. And now I can go back and do that first term. 2 squared is 4. That's negative 64 plus what we got for the middle term plus 10. So we got a y coordinate of 10.7, blah, 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 all this stuff. So 23.18. I didn't see what Newton wanted for this question for decimals. When I checked my work, I realized I did something wrong with the calculator. So for x of t, for the x coordinate, so cosine of 15 times 125 times 2. That should be 241.48 for the x coordinate, not 23.18.